All right, so welcome. Here we go, real time. What we're looking at is the multiple choice 2 no calculator, the 60-minute section that we did previously. I want to walk you through how I view the problems, and we're going to go from there. Number 1, let f of b defined as the following. So we've got a piecewise function, which of the following must be true. We're looking at the limit. Does the function exist, and is it continuous at that? Looking, is there anything that I can quickly define right away? Now, number 2, does that exist at some point A? Yes, that's right there. So obviously, that's going to work out. We're good there. It's not going to be one only. It could be the others. I'm going to check out then number 1. Let's see what happens. Now the limit, that I can factor. This is going to be x minus a over, that's going to be x minus a. That's going to leave us with x squared plus ax plus a squared. That's going to leave us with x plus a, which that factors, that's going to be a whole at x equals a. So that tells us our limit exists. So it's at least 1 and 2. It's not 2 only. Now, last check, is it continuous at that point x equals a? Well, we know that at x equals a, we're going to equal 1. So, well, let's plug in a and see what happens. We're going to have 3a squared over 2a. Nope, that is not continuous because that gives us 3a. It does not give us 1. All right, that means that 3 is out. We've got 1 and 2 only. Next up. Slope of curve at a point is defined by the limit. Ooh, I recognize this limit. This is our definition of the derivative. So I see that definition of the derivative. I know my function f of x is going to be x cubed plus x squared. And I know that by looking at this, knowing the definition of the derivative limit. Which of the following is the equation of the line tangent? All right, so tangent line to the curve, we've got point slope form, y minus y1 equals m x minus x1. So that is y equals f prime at some point that we're looking at. In this case, it's 1 x minus a plus the function evaluated at that point. We've got y equals our derivative. That's our function. Our derivative is going to be 3x squared plus 2x. Our derivative evaluated at 1 is going to be 3 plus 2 is 5. Boom, that's out. Boom, that's out. So we've got 5. X minus 1 plus f of 1 is going to be 2. So with that, so we got y equals 5x minus 5 plus 2 minus 5 plus 2 minus 3. And there we go. Next. Antiderivative. So the general antiderivative. I see there is this up to the 4th power. We've got the statement inside. We've got an x outside. Now I can expand that, but I don't want to do that. I can u sub since I have 2x squared inside. Now I also notice antiderivative of something to the 4th power is going to be something to the 5th power. So immediately, that's out. That's out. Let's see what's going to happen. There's my u sub. U is going to be 2x squared plus 1. So du is going to be 4x dx. There's that x dx. So 1/4 du is x dx. We're going to have the integral 1/4. Ooh, that's where that 1/20th or the 1/4 is going to come from. That's what I see as the difference in there. Integral of, we'll have u to the 4th du, and so since that's the 4th, that's going to be u to the 5th. I'm already 1/5. U to the 5th, at times 1/5 times 1/4 plus, oops, there we go. I'm just going to recognize it. I got that 20 right there. So it's the 3rd option. Next. All right, if f of x equals g of h of x, so chain rule is going to come in here. H of 2 is 5, h prime of 2 is -5, g of 5 is 3. All right, f prime, that's going to be chain rule. So f prime of x is going to be g prime of h of x multiplied by h prime of x. F prime of 2 is going to be g prime of h of 2 multiplied by h prime of 2. That's going to give us h of 2 is 5. So g prime of 5, that's 3. Multiplied by h prime of 2 is negative 5. So times negative 5, there's our negative 15. 5. All right, find dy dx. We've got something with x and y. That's our implicit differentiation. So d dx of, we've got x squared y plus secant y equals 8. That's going to do product rule, 2xy plus x squared times dy dx plus derivative of secant is secant y tan y. Get some more room, multiplied by dy dx equals 0. I'm going to subtract, I'm going to factor and divide. So dy dx is negative 2xy divided by x squared plus secant y tan y. I factored both of those terms in one. So negative 2xy, that's out, that's out. And there's my x squared plus, so got that. Next up. All right, f of x is that. What is the number c in the interval such that the line tangent to the graph at the point x is c is parallel to the line drawn through the endpoints of the interval? I've got this function. That's a parabola. Now 0, 4, we're going 0 to 4. We want some point where the tangent line is parallel to the slope, the line drawn through the endpoints of the interval. This is mean value theorem. So tangent line, that's f prime of c, is going to be equal to, we have f of 4, not 6, f of 4 minus f of 0 over 4 minus 0. So the slope between the 2 points is equal to the derivative at some point. So our derivative, that's going to be 12c plus 4. I just took the derivative. F of 4 is going to be 16 times 6. That's 96 minus 16 over 4. 16 times 6, yep. All right, so that's going to be 80 divided by 4 is 20. So I've got 12c plus 4 equals 20. I'm going to subtract 4. That's 16 over 12. And that's going to be 4 over 3. Uh-oh, that's not there. Guess I'm going to come back to that. Let's think about this for a moment. Plug in 4, 16 times 6 plus 4 times 4. Ooh. I missed that. So that's actually going to be 96 plus 16. That's going to give us 12, 112, 122, 122 divided by 4. So we've got 12c plus 4 equals 122 over 4. That's going to be 48c plus 16 equals 122. 48c equals 106. 106 over 48 is a little bit more than 2. A little bit more than 2 is that one. Does that work out? Divide by 16, divide by 16. That's not right. Something's off. But I'm going to come back to it. F be a function that is differentiable for all x. The value of f prime is given for several values of x in the table above. All f prime of x is always decreasing. That means that f prime prime of x is less than 0. F the point of inflection, well, it's always decreasing, so that can't be it. Relative maximum at x equals 0. We change from positive to negative, that's true. F of x is concave up for all, well, second derivative is negative because that's always decreasing, so it's concave down. 2 only. Integral, oh, definitely a substitution. I've got something on the inside, so u is equal to x cubed, then du is 3x squared. Hey, look, there's that x squared dx, or I've got x squared dx is equal to 1/3 du. So then I have 1/3 integral of secant squared u du. That's a nice easy one. That is 1/3 tangent of u. Tangent of u is going to be x cubed plus c. Let's check that out. There it is. Graphs of the function f and g are shown in the two figures. Which of the following statements is false? Limit as x approaches 2 of f of x is 1. Oh, that's true. Limit as x approaches 3 of g of x does not exist. That is true. G of x plus 2 as x approaches 2 does not exist. Well, that would be f of 2. Well, that exists. That's plus 2 plus 2. 2 plus 2 is 4. That exists, so it's false that it does not exist. F of x plus 1 is, we go to 2, so if we plug in 2, that's 3. That's fine. And if we plug in 2, that's fine. So that is true. Double negative in there. Chain rule, u sub, right there. We got something inside parentheses. U is the natural log of x. So then du is 1 over x dx. Ooh, there's that bit. That's going to turn this into 1 over 1, integral of 1 over square root of 9 minus u squared du. Oh, that's going to be a arc sine. I know it's definitely an arc sine. Don't need that 1 over x in there. I'm going to look between those two. If I factor out a 3, or actually factor out a 9, that's going to be 1 over square root of 9, square root of 1 minus u over 3 squared du. That's going to give me 1/3 integral 1 over radical 1 minus u over 3 squared du. 1/3, 1/3. I can do an extra w sub. So if I say w is u over 3, then dw is going to be 1/3 du. There's that 1/3 du. That would just be w. It's 1 minus w squared. So that's going to be arc sine of w plus c. W is that, u over 3, and u is that. So there we go. Number 11, y values where that has vertical tangent lines. Vertical tangent lines, that is dy dx does not exist. That's where we're going to be dividing by 0. So I'm going to take the derivative with respect to x. That's going to give me 3y squared times dy dx plus 2x plus 60y dy dx equals 4, and that gives me nothing. So here, I'm going to factor and subtract a whole bunch of stuff at once. We're going to have 4 minus 2x to move that over. We're going to be divided by dy dx. We'll be divided by 3y squared plus 60y. And that's from those two terms there. Now, it's asking for what are the y values. So we've got 3y. This is going to be y plus 20. So we've got y is 0, y is negative 20. Now I'm just going to take those values and plug them back in. Do we have outcomes, or do we have x values for those two? So if that's 0, that's 0. Yep, we can solve that. So 0 is going to work. If we plug in negative 20 cubed x squared, that's going to give us 30 times negative 20. So that's going to be 400 times 330 is 1200. Okay, that's going to work. We're going to get a solution because we've got the x squared and the x. Doesn't matter what happens with the y's. Nothing else is going to cancel out. So we've got 0 and negative 20. slope of function y is given by that. So this is f prime of x, because the slope is that. Inflection points, that's when f prime prime is equal to 0 and changes direction. So f prime of x, we've got 6x to the fourth minus 12x squared plus 2, then f prime prime is going to be 24x cubed minus, cubed tells me there's 3 of them, minus 24x, that's going to factor nicely, so that's going to give us 24x, x squared minus 1, and, well, we've got 24x, x plus 1, x minus 1. Thinking this is cubic, we've got those zeros, so we're going to, we're changing from positive to negative, said that backwards, negative to positive to negative to positive. So those 3 points are all inflection points. -1, 0, +1. Next up. All right, integral. I'm seeing x cubed, I'm seeing x squared, it's u sub. U is x cubed minus 6x plus 1, and du is going to be 3x squared minus 6dx. That's really close to what's up top. Du is going to be 3x squared minus 2dx. Factor it. So we've got 1/3 du is x squared minus 2dx. There's my sub. So we have 1/3 integral 1 over u du, and that's going to give us to the natural log. So 1/3 natural log of u, and u is all that stuff. And what's the difference between that? There's our number, that one. What's that supposed to say? Didn't catch that one before. Volume of a solid formed revolving the region bounded. Okay, so I'm thinking the volume of rotation. We are rotating, revolving. That's pi. It's going to be outer radius squared minus the inner radius squared dx. Now we have x squared plus 2, x plus 1. It's x plus 1. We know what that looks like. X squared plus 2. And we're going from x equals 0, x equals 1. So x equals 0 to x equals 1. And about the horizontal line, y equals 4. I know that's above that because if f of 1, or if we plug in 1 to our graph, to our functions, this is going to be 2. Well, that's going to be 2. That's going to be 1. That's going to be 2. Something's wrong. Oh, that's x squared plus 2, so that's actually going to be 3. So 4 is always above there. So we are going to have pi. This is our outer radius. So we're going to have 4 subtract x plus 1. So it'll be 4 minus x plus 1 squared minus inner radius 4 subtract x squared plus 2 dx, and we're going to go from 0 to 1. Okay, I see. Pi's all line up. Those all line up. 4 minus, this is going to be 3 minus x squared. So get rid of that, get rid of that. Next, okay, is it 6? Is it 2? That's 4 minus 2. That's going to be 2 minus x squared. And we've got the first one. Slope field. All right, shown above is the slope field of some differential equation, which could be a solution. So what's the curve that passes through that? I need something that looks like that. It's not x cubed. That would be upside down. That would be a lot. That's that. Plumber's accidentally crapped, blah, 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 blah. Rate is modeled by L. Following his best interpretations of L prime. So the rate, L is the rate. So L prime is the rate of the rate, meaning its second derivative. That's, I'm thinking acceleration. The rate at which water leaks from the pipe. So if this is liters per minute, this is going to be liters per minute per minute. So I'm looking the rate at which water leaks from the pipe in liters per minute, 5 minutes, nope. Liters per minute, okay. Liters remains in the pipe, absolutely not. The amount of change in liters per minute and the rate at which water is leaking during the first 5 minutes. So the amount of change, so nope, it's still not liters per minute. I want that liters per minute, since it's the rate of, you don't see my hand motion, so what I'm trying to do here. It's the rate of change of liters per minute, so it's liters per minute. That's the only option. And that f of x is continuous function. F of 2 equals 8. F of 1 is negative 4, which is the following by the intermediate value theorem. Everything exists in between there. So if we have negative 1 gets us 4, and f of 2 gets us 8, whatever our graph looks like, it's got to pass between there. F of x equals 0. I cannot say that. And actually, nope, that's between those are the y values. Those are, again, the y values. F of x equals 0. F of x equals 6. Well, 0 is not in between 4 and 8, but 6 is. That option. Intermediate value theorem has got to be between the y values on that x interval. Oh, this one, not even going to look at it. That is the definition of the derivative, because I've got the limit as h approaches 0. That's telling me my function is cosine of x, and we want to find f prime of pi over 3. Well, f prime of cosine is negative sine of x, so f prime of pi over 3 is going to be negative sine pi over 3. So that is root 3 over 2 negative. There, we've got that. All right, I see. Degree of the numerator is 2. Degree of the denominator is 1. Long division. I'm going to quick rewrite this. That's going to be x squared plus 0x plus 7 divided by x minus 3. So that's going to be x squared minus 3x. Subtract, it's going to cancel. We have 3x plus 7. That's going to give us plus 3x minus 9. That's 16. So plus 16 over x minus 3. This is the integral of x plus 3 plus 16 over x minus 3. All right, that's going to get us x squared over 2. So that's out. That's out. That's going to get us plus 3x. There we go. And the rest of that's all the same. There's the plus 16. There's the plus 16 if we want to go the step further. Okay, linear approximation to g of x is, that's our equation. Y equals 65x plus 65. So that tells me that g prime at 1 over 65 is 65, because that's the slope. And that's our input. G prime of 1 over 65, and I actually need that there. So g of 1 over 65, we can plug it in and approximate it. That's going to be 65 multiplied by 1 over 65 plus 65 minus g prime of 1 over 65, which is 65 minus 65. That cancels that. That gets us 1. F of x be the differentiable function defined on the interval. We've got the interval. We've got the derivative shown in the domain of the table, the equation of the line tangent to the graph of f of x, and parallel to the segments between the endpoints of what? Endpoints. equation line tangent to the graph and parallel to the segment between. So since it's parallel to the segment between, that tells me that this is another mean value theorem problem. F of c is equal to f of, well, 6 minus, we've got f of -6 all over 12, because that's 6 minus -6. So we've got f prime of c, that's going to be the point. F of 6 is going to be 0 minus -5 over 12. So that's 5 over 12 is our slope. That doesn't look right. Oop, I'm looking at the wrong values. I had to go 5 and 41. So that's going to be 5 minus 41 over 12. So that is -36 over 12. So f prime of whatever our point is going to be -3, whatever it's 6, -3. That's out. That's out. Let's check those 2 points then. When is f prime equal to -c? That point. So I've got y minus 13 is equal to -3, x minus -2, x plus 2. So we've got y equals -3x. That's -6 plus 13 is plus 7. Following a graph satisfies a differentiable function f of x that satisfies. So f of 3 is equal to 2. F of 3, nope. F of 3 equals 2. That could be works. That could work. That could work. Okay. F prime 0, 3, 5 equals 0. So that tells us horizontal tangents at 0, 3, and 5. 0, nope, that one's out. 0, 3, 5, nope. Not that. 0, 3, 5, 0, 3, 5. Okay, so those could still work. F of x is less than 0. Okay, so slope is going down. If x is less than 0, oh, it's got to be c, because that is slope is going up. 3 is less than or equal to 5, and, well, that's going up again. So that last statement invalidates the last one. Letter C. Given the following, which of the functions f, g, h has at least one point of inflection? All right, second derivative. Ooh, that one's already given us the first derivative. So g prime of x is going to be, it's going to be 15x squared. That never changes sign, so not 2. This one, sign, definitely has points of inflection, so I know 1 is going to work. Could be that, could be that. Got to check on h. So take the derivative, that is 6x to the -1 minus 1/2 x to the -2, just rewriting it, so h prime of x is -6x to the -2 plus x to the -3. Our second derivative is going to be 12x to the -3 minus 3x to the -4. That's I'm going to factor out that 3 there. When is this equal to 0? Divide by 3, that's going to give us 4 over x cubed minus 1 over x to the 4th equals 0, and the only time that's going to have a point of, oh, it's not entirely right. So I got 4 over x cubed is equal to 1 over x to the 4th. 4x to the 4th over x cubed equals 1. That cancels with that. So x equals 0 might be, but it's not in a domain. So there, 4x equals 1. That happens only when x is 0. So again, not in the domain. It's got to be 1 only. 24, dy dx equals that. And which of the following was the solution to the equation given that? All right, so we have a differential equation. Need to separate, always separate. We've got e to the x over e to the y. I just rewrote that exponent since I'm subtracting. It's going to be e to the y dy is equal to e to the x dx. Integrate both sides. And it's going to be e to the y equals e to the x plus c. Take the natural log of both sides. We've got y equals natural log of e to the x plus c. And we know this point, y of 0 is 1. So when x is 0, y is 1. It's 1 equals, group that, natural log of e to the 0 plus c. E to the 0 is 1, so 1 equals natural log of 1 plus c. That's going to be e is 1 plus c, so c is e minus 1. There's that. Graph of f prime is shown as horizontal tangents at 4, 0, 12, negative 6. All right, what are the points of the reflection of f of x? So this is f prime of x, so we want to know when that changes signs. So that's going to be at 4, that's going to be at 12, because f prime prime is going positive to negative, point of inflection. It's going negative to positive, point of inflection, 4 and 12. Function f is differentiable on the closed interval, satisfies f of 2 equals 5. We've got f of 2 is 5. Graph of f prime, derivative, consists of a semicircle, 3 line segments as shown in the figure. We're going to be adding areas here. What's the absolute minimum value on f? So absolute minimum value is going to occur when the first derivative is 0 or an endpoint. Thinking about, okay, candidates, it never switches signs at each of those 0 points. So that means our graph is going to be positive from that endpoint. It's going to be 0. It's going to be positive, positive, positive. The only candidate is at x equals negative 5. So we need to know the value of x equals negative 5. I'm going to go back. This area here is 2. This area here is 3. This area here, that's going to be 1/2 of 2 pi squared, so 1/2 of 4. That's going to be 2 pi. And we know that f of 2, okay, so that's just going to be pi in there. F of 2 is 5. So that means that f of negative 5 plus 2 plus 3 plus pi gets us 5. Oh, that cancels with that. F of negative 5 is negative pi. It's not there. So got to figure out something else. What did I do wrong? This is why it takes you get an average of 2 minutes. Sometimes you make a mistake every so often. We're going from, so that is 2. Verify that. Height of 2, base of 2, 2 times 2 is 4, divided by 2 is there. Base is 1, 2, 3. That's what I did wrong. 1, 2, 3, and then that's 1, 2, 3. So that's 9 over 2. So 9 over 2 is 4.5, and that's pi. So we have f of negative 5. Add to that 6.5 plus pi is equal to 5. So f of negative 5 is equal to negative 1.5 minus pi. There we go. That looks a little bit better. N is a positive integer. This is our definition, and you can see, of our integral. This is our delta x. We see each time what's happening. We're obviously going to be cosine. Pi shows up every single time, so there's going to be a pi in there. We don't want the n. So is it pi x? Is it pi x to pi? Here we are going from, pi just shows up every single time. That is from 1 to n. And I can see that, so we've got cosine of pi multiplied by 1 over n. That's 0 plus that much to get up there. We're going from 0 I know what it's supposed to be. Not that, because we're not going up to pi. We're not going to have that pi squared in there. We are going from, oops, we need the pi inside, so it's not going to be that. We don't want the n. There we go. So we can argue that is that. All right, given the function, we've got that k value in here. The function is a local minimum. That tells me that f prime of -2 is equal to 0. Point of inflection at -3, so f prime prime of -3 is equal to 0. And k, nope, blah, 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 we don't care what k is. We want the value of b. So f prime is going to be 9x squared plus 2ax plus b. And we know that equals 0. I'm going to go to the next step, f prime prime. 18x plus 2a. So we know that when this is -3, so that's 18 times -3 plus 2a is equal to 0. That's -54 plus 2a is 0, so a is going to be 27. Let's put that up here. Actually, I didn't need to find that because I needed to find 2a. Delete, delete, delete. That's 27. That equals 0 at x equals -2. Clear that out. So we have -2 is 4 times 9 is 36 plus minus 54 plus b is equal to 0. That's -18. So we've got 18. What did I mess up in there? B is 18. Where's the local minimum? 2, 4, 27, 36 minus 12, should be 18. Okay, that means that's, I've got something wrong with a value. Let's check that. So f prime of x is 9x squared plus 2ax plus b. F prime prime of x is going to be 18x plus 2a, and that's equal to 0. Plug in -3, that's going to be -54 plus 2a. 54, 36, yeah. So a is 27. 2a is 54. 2a is 54 times -3. Oh, multiplied by -3. Missed that bit. No, multiplied by -2. So that's minus 108. It's 36 minus 108 plus b is equal to 0. So then that's going to be -72. And a little arithmetic, missed the multiplying by -2 there. Time greater than 0, the velocity of the particle is moving along the x-axis at a given time by that. What time? Acceleration have a negative value. So acceleration less than 0. Our acceleration is given by, I'm going to use the product rule. That's going to be 3t plus 6 squared multiplied by t minus 3. And we're going to add to that t plus 6 cubed. Ooh, I can factor. It's going to get me t plus 6 squared is going to leave me with 3t minus 9. That's those two multiplied. Plus t plus 6. So we're going to have t plus 6 squared. We have 4t minus 3. When is that less than 0? Well, that's always positive, so I don't care. This equals 0 at t equals 3/4. I'm thinking that is a linear statement. It's going up, so 3/4. There's my sign chart. It's going to be less than 3/4, and there's only one value that is less than 3/4 up there. Last one. So out as a circular base of radius 4 with the center at the origin. That is x squared plus y squared equals 16. So x squared plus y squared equals r squared. Area of an equilateral triangle in terms of its side S is given by the formula that, which the following is the volume of the solid. So volume is the integral of our area dx. In this case, it's the integral of root 3 over 4 s squared. S is that full distance. S is 2y. Y is the square root of 16 minus x squared. So S is 2 times the square root of 16 minus x squared. So S squared is 4 times 16 minus x squared. So S squared is 64 minus 4x squared. Ooh, I'm going to bring that in. So we have root 3 over 4 times the integral. I'm going to take it back a step. 4 times 16 minus x squared dx, and we are going from 0 to 4. Oops, negative 4 to 4. I can go from actually 0 to 4 and double it because it's symmetric there. That 4 and that 4 will cancel. We have 2 root 3 multiplied by the integral of 16 minus x squared from 0 to 4 dx. So that's going to be 16x minus 1/3 x cubed multiplied by 2 root 3. Evaluated from 0 to 4. If we plug in 0, everything's 0. So we've got to plug in 4. We've got 2 root 3. That'll be 64 minus 64 over 3. 64 over 3, that's going to get us to root. 64 times 3 is 128, 180, 192. 192 minus 64. Oh, that's going to be 128 over 3 times 2 root 3, getting us 256 root 3 over 3. So that's what we got. Check it out. I think number 7 might be a little bit off. Go back to that one, always thinking about that. Work smart. Cross off what you know is a garbage question. So number 7, nope. Number 6. I think that one's good. But, all right. See you later.